over 40. And anytime you see an or in probability statement, it's an and or. Okay, it's like a person is a man, or is over 40, or both. Okay, so anytime it's an or, this implies man or 40 or both. Okay, so that's what the or statements always mean. Okay, so there's always an or both.
That's why you're not doing 5 instead of 10.
So, okay. So there's several ways we can answer this. Okay. So one is I could break up all of the components of being of men, and I could say, adding up the different boxes, I'm going to do 25 over 93 plus 10 over 93 plus 5 over 93, and then 5 over 93 for the 40 plus. Another way, and I hope you guys can follow me. So this is 45 over 93. Another way is I could say there are 40 men, 40 over 93 men, and then there are 10 people who are 40 plus. Okay? But I have double counted one of the groups, right? So 40 means I've added these three numbers, okay? And when I add 10, it means I'm adding those two also, okay? Which means I've double counted this one. I only want to count them once. So what I'm going to do is I'm going to subtract off the part that overlaps, okay? So in this case, this is probability of being a man plus probability of being 40 and up minus the double counting. The men who are, so man and 40 plus. Okay. Is that okay? No. You're shaking your head. What's not okay?
On the top of this was 25 plus 10 plus 5 plus 5. And here you're saying plus 10. What would you do?
Okay, so what is 25 plus 10 plus 5? It's 40. Okay. So these three numbers are included when I do the 40 here. Okay. So really, I only need to add 5 more. Okay. Now it seems silly to do it this way, but sometimes your table is huge. Okay. And it's like, oh man, I'm gonna have to add up like 80 numbers because I've got 70 columns and 10 rows or something like that. Okay. So sometimes it's easy to miss the column that we want to do. So sometimes it's easier just to add up the entire row total or the column total, okay? But if we do that, okay? So if I take the row total, which is 40, which actually represents 25 plus 10 plus 5, okay? And if I add on 10, which actually represents 5 and 5, okay? What I've done is I've double counted the 5. Does that make sense? Okay, I've double counted the 5 there. So I have to subtract off that bit that I double counted. So I only count it once. Okay. Does that make sense? So maybe you can think of I can't think of a simple example that makes it super relatable, but here's an example, okay? And so in the general form is that any time we see the probability of two events, and let's just call them event A and event B. If I say what's the probability of event A or B happening, this is going to be equal to the probability of event A plus the probability of event B minus the probability of event A and event B. This is a general rule. did I use this rule? Alright, did you guys get to write that down? Alright, okay. Did I use this rule for these situations up here?
No.
No. Why not?
There's nothing
Because there's
overlap.
no
A and B
overlap.
wasn't work together.
There's no overlap, okay? So if I said, what's the probability of being 18 to 24 or 40, okay? I took the column for 18 to 24, and I took the column for 40, and I added those up,
No.
and I had no overlap to subtract, okay? Because it's impossible to be in the 18 to 24 group and exactly at the same time be in the 40 plus group, okay? And then for the men or women, I just took the male total and the women total, and I just added those two together, and I had nothing, no overlap to subtract, because it's impossible to be categorized as a man and at the same time be categorized as a woman, okay? So actually, this rule still holds true. This still holds true, it's just that the overlap is equal to 0, okay? So if we did probability of being in the 18 to 24 group or the 40 plus group, it's still probability of 18 to 24 plus probability of being 40 plus minus any overlap. Okay, and this is 55 out of 93 plus 10 out of 93 divided minus 0. Okay, 0 over 93 or whatever. Okay, so that rule still holds true. It's just that there's no overlap. Okay. Anytime we have two events that have no overlap, we call those mutually exclusive events or disjoint events. Okay, if two events have no overlap, they are mutually exclusive okay, also known as disjoint. So, are the events man and woman mutually exclusive or not?
Man and woman, they are disjointed, yeah.
Yeah, those are disjoint. You cannot, there's no overlap. You cannot be a man and at the same time be a woman. Okay? I mean, at least according to this, in this table, okay? In this table of 93 people, there is no overlap of men and women, okay? You know, in life, it's gotten a little bit more complicated, okay? But, yes?
So complements is always be mutually exclusive?
Complements are always mutually exclusive. Very good, okay? Because there's no overlap, right? Okay, yeah, complements are a special case of mutually exclusive events, in that the complements form everything possible, okay? But you can have mutually exclusive events that aren't necessarily complements, which is what we saw here, 18 to 24 or 40 plus. You can't be categorized as 40 plus and at the same time categorized here, but they aren't complements, okay? Good, very good. Okay. Let's take a break. And we'll come back in 10 minutes here.